Hey everybody, welcome to Math Muscle. Mr. D here. Just checking in with an example of a classification of points given a function where the first derivative equals 0. We're going to do part A together now. You can see that below I've actually already started the question. So the first part is to take the derivative, which has been done already here using the power function, and then common factoring and trinomial factorization, so that will allow us to find the roots, where the first derivative equals 0. Once you have the value or values, in this case there are two, x equals 0 and x equals 2, you create a sign diagram for the first derivative of f, and you put in on the sign diagram the actual critical points or stationary points where the first derivative equals 0. So you have x equals 0, x equals 2, put on the sign diagram, and then from there you determine test points that fit in each of those three intervals. So you've seen below I've already included the test points of x equals -1. In the center interval there's x equals 1, and then on the right hand interval is x equals 3. From there you substitute in those test points into the first derivative function, and I actually used the factored version right here of the first derivative function. That makes it a little easier because really all we're wanting is the gender or the sign of the first derivative. So we substitute in -1 into 12x. 12 times -1 is a negative value. -1 minus 2 is another negative value. -1 minus 2 again is another negative value. When you multiply three negative values, you end up with a negative. And that's what's really important for us to note, because when the first derivative is negative, as is noticed in the sign diagram, then that tells you that the original function is in fact decreasing, hence the arrow. And do the same thing for each of the other two test points. X equals 1, substitute into the 12 times 1, 1 times -2, 1 times 1 subtract 2, 1 subtract 2, and you'll get a positive times a negative value, and that in fact is a positive value. So you can see how in this case here we actually have a positive first derivative, because when we substituted in our +1 in for x, we ended up with a positive answer. And the same thing happened when we substituted in x equals 3, we ended up with another positive answer, which means the function, the original function, is increasing in each of those two intervals. So in terms of answering the question, to classify the points where the first derivative equals 0, because the function is decreasing to the left of 0 and then increasing to the right of 0, so in other words the function goes down and up like that, then basically we know that there's a local minimum at x equals 0. Because we know there's a local minimum at x equals 0, then we can substitute that into the original function. The original function being the one that's given. And when we substitute x equals 0 there, we get a y-coordinate of -9. So therefore the local minimum of that function is at 0, -9. So that's the solution for part A. I hope that helps you determine where the first derivative equals 0. But also we can actually answer part C as well, the intervals where the function is increasing or decreasing, because we've actually done that already. So why don't we go ahead and do that for part C. So this is part A. Part C, from the sign diagram below, we can see where it's increasing. It's increasing on the interval of 0, 2. So that's the interval, not including 0 or 2. Decreasing. It's decreasing on, actually it's increasing in two intervals. So it's 0 to 2, and from 2 to positive infinite. It's decreasing from -infinite to 0. So I hope that helps. Please subscribe to Math Muscle, and if you're interested, you can actually request some videos that I can help you out with. Thank you.